No. Okie dokie. Today we're doing applications of exponential functions, which means story problems.
Okie dokie.
Johnston, put it away. We're doing a new lesson.
Oh, you want me to follow along?
Yes, I do, because it's new stuff.
You know, it'll take me longer to read the story problem than it will to do that in the actual work.
Is this somewhat easy?
Oh, yeah. No, it's
Is
extremely easy.
Is this actually?
Yeah.
Now.
It is actually easy.
You, Mr.
What?
Taking in,
Is it easy enough to do in your head?
taking in our brains.
If you know what base e to an exponent is, then yeah.
Oh, it's easy.
If I know what?
Base e to an exponent is.
I know what E is and exponent is. Wait, doesn't it cancel?
Is that pen?
Base
Take one instruction.
Base E of E.
You're welcome.
It's pen.
Oh,
I'm sorry.
One doesn't cancel. Base
No, it
E.
does not.
Base e to an exponent.
Can we do a class vote to single lesson?
No. No, you cannot.
But that's like a class
If you do the lesson today, you can all get through that.
Okay, so when we are talking about exponential applications, there are two types. There is exponential growth, and there is decay. So growth is when something is getting larger as time passes. Decay is where something is getting smaller as time passes. When we talk about exponential growth and decay, we're always starting with a principal amount, and then it's either growing or getting smaller from there. There are a few applications that are the most common. These usually are rooted in finance. So interest accruing on bank accounts. When we talk about interest, there are two kinds, and this is usually under growth. Applications. A compound interest has the equation our amount equals our principal times 1 plus our interest rate divided by the number of times per year that we calculated, all taken to the n times t. How is that funny? Okay.
You probably thought of a joke here like we can have.
We also have continuous interest. This one is very similar, but it is the equation A equals our principal times E to the interest rate times time. For both of these,
Where are you getting all those terms in?
the P and the R and the N,
Yeah.
they all stand for different things, which I'm about to outline right now.
Where's your source?
So P equals the principal amount, or the amount that we're starting with. So if you are heading into a bank right now to open a bank account and you put $1,200 in, that $1,200 is your principal amount.
Starting.
Yes. N is the number of times per year that interest is accrued. Or interest is compounded.
What's that mean?
So if I say quarterly, then every 3 months, we're going to take 6% of whatever you have in your bank account, and we're going to add it to your bank account. So that's how often the interest is being calculated. Our R is the interest rate written as a decimal. So if I say that your interest rate is 6%, that is the same as 0.06. If I say your interest rate is 12%, that is the same as 0.12. And then T is the time in years that we're calculating. These are all the same no matter if we are compounding continuously or at certain intervals throughout the year.
Thanks, class well as raining.
Give you guys a second to finish this one, and then we will go ahead and get started with an example.
Calculus?
Since green changes my joke.
This is the accounting class. Oh, she's showing this.
Are we writing this? Example, Julian had 5 apples. He takes a friend of his named
27 watermelons for his.
a friend of his named Amelia takes 2. How many does Julian have?
0.
Julian has 3.
So then we have 1 is already the word process.
I hope you were writing as you were talking.
Absolutely.
I read out the example.
Yes.
What's the point of an example if you don't know what you're doing? Never do the entire
That's the
story.
point of the example, so you learn how to do it.
Exactly, so write it down.
How to write down the equation.
How about you write the example?
Is ACCT
Account.
account
Yeah.
abbreviated?
I know, at least change the name to Devin.
That's right.
Alright, see that? This is just-
Make it more relatable, Devin.
How do you write so fast?
Just write.
Yeah, I know what.
So this is the example we're starting with. Julian invests in an online savings account, earning 8% interest per year. How much will be in the account at the end of 10 years if the interest rate is compounded quarterly and she put in $10,000?
So you gotta find.
Hold on.
8%.
Let's let people write it first.
You're Australian female, so she's a cheater.
You know, it's easier to write he than it is to write she.
Why? Because it's one less letter.
Yeah.
But like, it's disrespectful to change the question, it's just be one.
Constant Tinger. Wish I could just hit Tinger.
I actually had that same thought while I was writing these problems.
No, you already have a job, so save up.
Wait, is this person a he, she?
Did we
We don't
change
know, it's
pronouns?
2020, what kind
Yeah,
of
it
pronoun
says
are we supposed to use?
Julian on my CV.
Oh, yeah.
How much-
Apparently.
How much will he have in 10 years?
I see
How
it.
about really the she
Oh,
about
yeah,
it?
now Devin.
That's okay.
Assuming Devin has the name.
It's a good thing we're not assuming with her gender.
Exactly.
It's a unisex transaction.
I like it.
It's like Devin.
Okie dokie. I have a question. At the beginning of this, we outlined 2 interest equations. Which one are we going to use? Compound or continuous?
Compound,
How do you know?
because it says compound in quarter.
Correct. So the only way we would use the continuous one with E is if it said interest compounded continuously. It has to have the word continuously in there in order for us to use PERT.
What does it mean? What's the difference though between the continuous?
Every second of every day it's taking your interest versus waiting till a specific time in the year.
Okay.
So I'm assuming the use of compound.
Compounded.
Okay, so now we go ahead and pull out the information. How much money is he or she depositing in the account?
10 grand.
10,000. So that is my principal amount. What is my interest rate?
Is
Point
it
zero
8%, which we write as 0.08. How long is this money sitting in the account? 10 years, so that's our T. And then last one, how many times per year am I taking interest?
4 times.
4 times because it says quarterly.
Wait a second, I have a question.
What?
We'll use this in the real world, won't we?
Yeah, this is a legitimate application.
About time you learn something.
Some of the
next
next
letters.
Okay, so now let's find out how much money he or she will have after 10 years. So I have my amount is equal to my principal times 1 plus my interest rate of 8.08, divided by the number of times per year I'm taking that interest rate, all to the number of times I'm taking the interest rate per year times the number of years. So I just plugged in the R, the N, the T, and the P.
Why is it just the one, not the T?
So.
It's a 10.
10 years.
No, inside the parentheses.
That's not a T, that's a plus.
No.
It's always a plus, it's always a 1 right there.
Don't you think
Okay.
the word continuous or continuously is a word?
I think it's a fun word. Anywho, let's do math.
The 40th part.
Okay, so if you're gonna plug this into your calculator, you need to be really careful about how you're doing it. I prefer you simplify within the parentheses first. So we would want 10,000 times, I would simplify the 1.08 or 1 plus 0.08 divided by 4, which is gonna be 1.02 to the 40th power. I would do 1.02 to the 40th first, and then multiply your answer by 10,000. If you try to do too much at one time and you don't have parentheses in the correct spot, or you plug it in wrong, it's going to mess you up.
22,008.
24.
After 10 years, she would have $22,080 and
$80.
$22,080.40. Which is pretty decent for a 10-year savings account.
That's okay.
Oh, wait, then we times 10 grand.
That's just on interest plus whatever.
Right, like she doubled the amount that she put in there just from interest.
She actually overdone
Well, yes.
And if she adds more, it'll change.
Do they actually have an 8% interest rate?
Some banks, most of the time, it's gonna be like a 3.5%.
It's like 2 or 3%.
Yeah, they're not that high, 4%.
Unless
Unless you go into like a high stakes one, in which case it might be a little bit higher, or you put it in and you can't touch it for 50 years. Those are usually a little bit higher too.
50 years. I think you might be dead by then.
There's a reason people don't do it. Okay. Are there any questions about how we plugged it in, or why we plugged it in, or how we got the answer that we got?
But there's some people who just pass off to the kids.
So what about the fact that there's no way they're gonna let all that money sit in the.
If their kids are smart, they'll leave it in there for them.
I couldn't hear what you said because Jeremiah was talking.
Wow. So in reality, this wouldn't work because there's no way to let that 10 grand not be touched that entire time. with
You don't know that. Maybe that's chump change. Maybe she does not need it. Chump change.
We do it all the time. If you put in if you have a high interest banking account, you put in $1 million, you'd be like in the lottery or somewhere, you put in 5 or 10 or whatever, you'll have enough to live your salary enough, just getting interest every year.
Okay. Are we ready for the next part? Let's say that Julian took this 10,000 and put it into a bank account at 8% interest, but instead of being compounded quarterly, it was compounded continuously.
So
So same information,
what's that gonna find us? It's gonna find us.
but now the account is compounded continuously. Can I use the same equation I just did?
Yes.
Sure.
No.
Is that gonna find us how much
Hold on.
he's making like per second?
That means it's changes thing.
So now I want an account that is compounded continuously, which means I use the other equation that we have,
A equals P to the RT.
which is A equals PERT. I like to call it PERT.
Birdie.
It's still gonna tell me the same thing. I'm still leaving it sit for 10 years. And I still wanna know how much money's in this account after 10 years, and then compare that to how much was left in the account that was compounded quarterly after 10 years. So still using the same information. I still put in 10,000 to start. E is the base. My interest rate is still 8%. It's still sitting in there for 10 years. But now there is no N because it's constantly being compounded. So we go ahead and we plug that into our equation. 10,000 is my P value times E, which is on your calculator, to the 0.08 interest rate times 10, which is how many years I'm letting it sit for. In your calculator, you're going to want to do the E to the 0.8 first, and then multiply that by 10 grand. Should be by natural log over on the left-hand side.
Oh, you gotta hit second, right?
Yeah, usually it is.
Isn't D just like a gigantic number?
It's like 2.7 or something.
What is E? 2.2.
It's a base number. It's a constant like pi.
Oh, wait, I forgot
$225,200.
to put
What makes no sense to me is how did they figure out the number for pi and then look how it never ends?
It wasn't so
41.
much a number they just figured out. It's a constant ratio that shows up many places in nature. So they tried to figure out what it was and they've been unable to because it's a never-ending irrational number.
So it's
But how do
So they
not
didn't just
know
make it.
How do they not know it doesn't repeat at like the 10 million number?
Well, they've gone out to like millions and millions and millions and millions of digits and found no repetition.
Why?
Because it can't be expressed as a ratio, which means it will have no repetition ever.
It's just
Okay,
something really boring.
so if it is compounded continuously after 10 years, Julian has $22,255.41 in the account. Which one of those is a better option?
The E.
The continuous. It came out with more money after 10 years with the same initial principal amount put in at the same interest rate
So
after the
this-
same amount of time.
So doing these two equations is what's gonna help you decide what you want.
Which
Is it
one will give
always
you the
better?
best payback? Yes.
I like what they got.
Is it always better?
No, after a certain amount of time, it's better, but not always. There are always going to be times, so it's always good to check. Often, though, the continuous will be a better deal, just typically.
You know, if you had just 10 years ago, like, just spare some money with
Okay, let's do another one.
10 years living in poverty, but like after that, you like double the amount of money you can spend.
Steven? Okay, so now we're going to apply it to to a population problem
Alvin in 1990.
in.
Oh,
When
What do you mean, natural?
natural Roman numeral.
One hand. Natural log. The base of 1990.
is everyone else that's in this class like virtual?
Well, there aren't a whole lot of you.
There's
I know, I'm talking about like Zach, Leslie, Jonah.
Yes, for right now. Say hi, they can hear you,
Why are they virtual?
because they are.
Oh,
Why is that any
Zach.
business of your own?
It's not. That was
When they have COVID, it's his business.
It actually is not.
But like, what if
If he is at risk of getting it, he will be contacted.
that they McDonald's should be shut down too, just in case?
So is this what our homework's going to look like?
Hopefully everyone tells me.
I think I only put 5 questions on there, maybe 6. I could be mean, I guess.
I don't know.
Remember Ringle's number?
Never had her head or.
And
Lord always had like.
She had like 13 questions with
Actually,
6 parts
great.
each. It was like A through G.
Looked up everyone
It's
else
like-
and actually great.
Okay, so this problem says in 1990, approximately 999,290 people lived in San Antonio, Texas. The population has grown by approximately 1.28% per year since then. Use this information to estimate the population in 2009.
Wait, did you just like come up with this at the top of your head?
So if we Google that up, we can probably find the answer already.
Oh, no.
Well, it's not going to give an exact, but it should be pretty close here.
But no.
So is this
no,
actual
it's good.
facts?
Huh?
This is
Like,
compounded.
this actually happened?
This is compounded, right?
What?
But this isn't making accounts.
Population has grown. Which means
Okay,
It's
Johnston, say that again.
Is this compounded?
Is this compounded or continuous?
compound.
How do you know?
because it has grown.
Well,
It's still not going.
Continuous also
Because
grown.
Because it's every year.
because it's every year and a census is not taken continuously, so we're not constantly keeping track of, oh, 5 people were born, but 3 people died, so what does that say? It's just taken every year, and then that population is compared, and that's what they use to develop this interest rate. So we're going to be using the compounded interest equation that we started with, which is the p times 1 plus r over n to the tn power. We still have the same information. My principal amount is the population in 1990, which is 999,290. My interest rate is the 1.28%, but turned into a decimal, so 0.0128. N, which is the number of times per year that this interest is taken, is just 1. Whenever we talk about a population, it's pretty much always 1. And then T,
Why is
because we only take population once a year.
Oh.
Remember, it's not continuous, we're not always checking.
T is 1
What's the T gonna be?
29.
How did you get that?
there's 20 years from this.
I'm comparing in 2009, which is 29. Is it 29?
Yeah.
19 years
Oh,
from 1990. So T
I'm
here
stupid.
is
so
going to be
don't-
19. I'm gonna take this information and I'm gonna plug it in to that equation or formula we started with. So the amount I'm gonna have is my principal times 1 plus 0.0128 over 1 to the 19 times 1 power. Of course, we can simplify this. Put the 1 and the 0.0128 together to get 1.0128. And then 19 times 1 is just 19. You're going to want to do the parentheses to the 19th power first, and then multiply your answer by 999,290.
That's a lot of people. Yeah, like 1 million.
And you should have gotten 1,272,452 and 0.86. So we would round that up, obviously.
Because you can't have that many.
Yeah, you can't have a percentage of a person. That's not how that works.
They were giving birth like right there.
So you could say 53. Questions, concerns, or issues with that one?
Nope.
Did anybody not get it to work out? Landon, you still working on it?
Oh, that's about just admin now. So.
Okay, that's fine. I will say that when we're talking about population growth, it's only good for so long because then different generations might have a different growth or decrease rate. Okay, so make sure you're keeping that in mind. This will not go on forever. It will not continuously grow at 1.28%. So I have a follow-up question. What would the population be in 2019? Find out right now.
Another 10 years, so it's gonna be 29.
On your paper, figure it out. What's the only thing that's changing?
Well, what if the people?
The T.
Yeah.
I'm changing it from 19 to 29
But what do you use the new number?
Nope.
Why not?
because I don't need to. You could, but then you'd have to do 10 years instead of 19 years. But we always like to start with our principal amount, which was the population in 1990. This was backwards.
1,445,035.
Say that again,
1,445,000.
which we would say 36. You should. So 1,445,000 and 35.87. So I round that up to 0.36. Not 0.36. 36, since we can't have 87 hundredths of a person. Questions, concerns, or issues with that? We have 2 examples left and we are done.
What does that have to form? One's just form
They're still a person.
It's a half person.
No, they are still a person.
When you lose your arm, you're not a full person.
Yes, you are.
One's just born without an arm.
You're still human.
You guys are driving me nuts.
You're still human, but you're not a full person.
Oh my gosh.
You're still 100% human, but you're like 65% human. Percent person.
About cyborgs, you know, it's human. No, emotion. You're 100% human. You have a
I bought a new car, like 22,000.
Official.
More money, can I just get this one?
No.
It's like a Lamborghini.
Most trucks are.
Minus like $3 million.
Chunk change.
Right. You know, and chunk change.
think every time we pay taxes on our bills, we should all spend one money and it goes to rent and live in tax that year. Why don't the odds of someone being in the library?
Bow.
So this problem says you buy a new car for $22,500. The car depreciates in value at 25% per year. What is the value of your car after 1 year?
0.
Am I compounding this depreciation value continuously or once per year?
Once per year.
Once per year. So we're not using the PERT equation. So let's go ahead and write out the information. My principal amount, of course, is what it was valued at when I first bought it. N is just 1 because I'm taking this 25% depreciation once per year. T is 1 because I just want to know what it is after 1 year. R is not 0.25. 0.25 indicates that it's growing in value at 25% per year. Because it's depreciating or going down, it's negative 0.25.
Wait.
What?
No, I have. It's not how it works. How'd you get your T in your?
It said after 1 year, so that's T. And then N is just depreciating in value once per year, because that's when they take the interest.
Why was there
T plus options.
for you? I don't know.
Okay. So we plug it in. Steven, stop talking. So I have 22,500 times 1 plus negative 0.25 over 1 to the 1 power, because we only take the value once per year and we're only doing it after 1 year. So I could rewrite this by combining the 1 and the negative 0.25. And then this becomes 22,500 times 0.75. Because 1 minus 1/4 is 3/4. And I can just plug that into a calculator. Steven, I want to know what answer you get. Yes, you do. I know, it's the end of the world.
Can I use my phone?
No.
It's closer.
You can use my calculator.
No.
He's like, screw your calculator. This one's better.
My calculator.
Wow.
I'm gonna get the answer.
I have an idea. 1 minus 1.25, and that becomes negative.
It should be 1 minus 0.25, not 1 minus 1.25.
Well, no, but I think it's negative. And 1.7 negative. So I just.
Honey, there's a negative down at the bottom next to or right by the equal sign.
Oh, I didn't know that they existed. Am I just times by 0.75?
Yeah.
Sir.
I didn't even have
What'd you get?
some number. 16,875.
Anybody else get 16,875?
No, I got
Yeah.
16,875.
That is correct. So after 1 year, that's how much this car would be worth. What would it be worth after 5 years?
No, I don't believe that.
Go ahead and figure it out. 5 years. We do not make the rules, we just follow the problem. 5 years.
They don't offer that much.
5 years.
Oh, it does around 25%.
5 years.
Figure out how much it's worth. After 5 years, if after 1 year it's down to 16,875.
5 years is the exponential.
It's gonna go into negative value. You're at the pace.
Just do it. Just do it.
My problem doesn't make you a factor.
5,339.4.
The only thing we're plugging in that's different is that our T value is 5 now, not 1, because I want to know after 5 years how much it's worth. And it should come out to $5,339.36.
I don't truly believe that.
Well, no car should depreciate at 25% per year. It's just an example.
And not only that,
Because
like,
maybe you don't even
it's
drive
always
it.
What's Elon Musk's deal? Like, is it Cybertruck?
Yeah.
you can always
Maybe
sell.
make render better graphics.
Okay. Anybody have an issue with plugging this in?
Not at all.
Nothing at all. Okay, I have one more problem for you, and then you can do your homework.
Awesome. I was expecting something. Why do titles always have to be like so daunting?
So we're literally just using these two equations.
Yep.
The hard part is finding the information they use. And last one,
Reality, you have
Yep,
to-
last one.
I'm using different for that.
I don't think she should let you.
That's not realistic.
invested $2,000 into the pumpkins. That we never got.
I'll flex on this with Grant.
Oh, this is
Is this
way
a
too
true
realistic.
story?
You actually did this, didn't you?
You don't know.
This is a true
I
story.
do know that.
Why?
I'm gonna tell her.
Now it's a surprise. This is gonna be her 16th birthday. Her birthday gift.
Probably.
You think you'll still be teaching when she's 16?
I think I'll still be teaching. I don't know at what level.
I'd be a professor.
That's my end goal.
Oh,
Moving up 1 year, 3 years, say, it's your teacher.
We need to move schools if you want to get those.
But I'm already going for my master's, and eventually I want to do my PhD. Yep,
Are you gonna go back to school while teaching in school?
I am right now.
That's a lot of work.
yeah, so
Why
don't
don't
give
you
a
just
crap
teach-
for not having
Why don't
stuff
you just
free.
teach at the school where you're currently learning?
Well, I have to have my master's to teach any college level course.
Just teach there, you write yourself the answers.
Especially now.
Dang.
So that-
All right, the whole essay.
So if they really teach you sell it up to 2000.
It has middle.
Okay. So we're testing this with 3 different types of interest. One, where interest is compounded annually, which means once per year. One, where interest is compounded monthly, which means how many times per year?
Oh,
12, so that'll be our N. And then ones where it's compounded continuously. So which equation will I use for that one?
Continuous
The
compound.
E one, the PERT. So then what's the principal amount that I'm putting in?
Oh.
2,000. What is the interest rate?
5%.
Which is written as a decimal?
wait, so which one?
0.05. T is what?
18.
And then the N is going to change based off of which one of those 3 you're doing. I would like you to do all 3 of them to compare your answers.
This is an extra homework problem we weren't supposed to have.
Are we gonna have next like this where it's gonna be 3 parts?
You never know.
So 0.5 is going to be the.
0.05
I meant that.
is going to be your interest. Yes. Now find all 3 of those balances.
So is it to like the exponent of R?
Is R
For the continuous one?
is R 18?
No, T is 18. R is your interest rate, which is 0.05.
Wait, what is I? Wait, there's no I.
There's no I.
How do you spell per?
So T is 18. And then N is the last thing I'll say.
N is the one that's changing for each of those, yes.
So N would be 1 for A. 1, 12, and continuously, which is. What was the time for that?
What
Still
does
18
N
years
stand
T.
for? What does N stand for?
Or not the time.
N is the number of times per year it's compounded. There is no N in PERT.
So annually it would just be 1 then?
Annually would be 1. Biannually would be 2, because that I think appears on your homework. What's your question? Say it from far away. I don't want to get up.
How do you, when you're doing your exponents up there,
Mhm.
I got 0.9, how do I
How do you get 0.9?
18 times 0.05.
No, it's the n that goes in the exponent, not the r. So it should be for the first one, 1 times 18 for that first exponent.
I'm doing it.
Yeah, but if
It's still RT. Oh,
there's no end.
you're on the continuous one. Okay. So you just do e to the 0.9. And then multiply it by the 2,000 that you put in originally.
To the point.
That's.
If you said it was 0.9, yeah.
How do I do that?
You're gonna press the E button, and then it's gonna take you automatically to an exponent. Just type in 0.9.
Do you want us to round up to the nearest power?
It should anyway. No, I want exact change.
Did you have to do this stuff for your daughter?
You, of course, I opened a savings account for my daughter.
No, did you do all this math though? Did Jordan do all
Well, yeah.
this? Do it.
Dude, I'm a math teacher.
I'm so comfortable with this. This one.
I know.
Says 116.
Well, where did you get the $2,000 from?
Jerry.
I think I know where you get the $2,000
I
from.
have no
You
clue.
sold your husband's car, and then you bought him a moped, and
No, I
put
definitely.
$2,000 in the account, and then with the change, bought shoes.
Okay, so let's go ahead and look at these together. The first one is annually. That's fine. So I have my amount is 2,000 times 1 plus 0.05 over 1 to the 1 times 18, which is just 18. And this comes out to what amount of money?
4,000.
Yeah.
Yeah, that's what I had.
Monthly is going to be the same thing, except this n is going to be 12, and I'm going to multiply the 18 by 12 as well.
4,800.
Hold on. And we get what, Stephen?
4,865.
No,
4,900.
4,910.02.
My calculator wrong.
And continuously, I got.
And then continuously, hold on, let's set it up first. A equals 2,000 times e to the 0.05 times 18, which comes out to what?
2,102.
Can't believe it.
4,919.
Yeah, I don't know how you guys got that, but.
$4,919.20.
Do you have to hit the time button when you hit E?
Wait, what? Wait. How did
We will address how we got it in a second. I'm not going to do it for the recording.
how did we have to do, why did we have to do 12? Oh, wait, because.
Because NT.
The number.
Yeah, that might be what
Which
you forgot.
also, the 0.05 divided by the number also
Yes.
means that I did not know, and I
I
got
did too with the
each
12.
number.
Got it. Yep, that would do it. Okay, so those of you who are online, the homework is posted on Canvas. Please feel free to go ahead and work on it. Questions, let me know. I will stay on the Google call until the end of class.